All right, let's dive right into the heart of what makes tilapia farming successful: broodstock management. In this explainer, we're going to break down how the top hatcheries select, maintain, and even genetically engineer their fish to get the absolute best performance and, of course, profitability.
We're going to tackle this in three main parts. First, how do you even pick the perfect parent fish to begin with? Second, once you have those star players, how do you keep them healthy and productive? And finally, we'll get into the really cool science behind the supermale technology that has totally changed the game for this industry.
So, let's kick things off with Section 1, Broodstock Selection. And let me tell you, if you get this step wrong, the whole operation could be in trouble. It really all boils down to the quality of the parent fish you decide to build your farm on.
So, what exactly is broodstock? Well, to put it simply, these are your elite fish. They're the best of the best, carefully chosen and managed for one single purpose: to produce a non-stop supply of healthy, top-quality baby fish, we call them fry, for the hatchery.
Now, the genetic checklist for these fish is incredibly strict. You need a lot of genetic diversity to avoid the problems that come with inbreeding. You're looking for fish that are just naturally programmed to grow fast and survive well. They also need a strong, built-in resistance to disease. And here's a big one: a low feed conversion ratio, or FCR. That just means they get bigger using less food, which saves a ton of money. And of course, they have to be totally free of any genetic defects and be a good fit for creating all-male populations.
Physically, these fish have to be real troopers. They need to be able to handle warm, tropical water with no problem. They've got to be mature and fertile, producing high-quality eggs and sperm. They also need to respond really well to special high-protein diets that get them ready for breeding. And, this is key, they have to spawn reliably, right on schedule. In a hatchery, consistency is absolutely everything.
And then we get to health and biosecurity, and these are completely non-negotiable. The parent fish have to come from certified disease-free sources with absolutely zero signs of sickness, damage, or stress. You really have to think of them as the clean, certified foundation that the health of the entire farm is built upon.
This brings us to the number one rule: quarantine. Any new fish brought into the facility, especially these special genetic lines like the YY supermales, have to be kept in strict isolation for a period. This isn't just a suggestion. It's the most critical line of defense against some foreign disease coming in and wiping out your entire stock.
Okay, so we've picked our all-star fish. Section 2 is all about how we keep them that way. See, this isn't a one-and-done kind of thing. Maintaining that quality takes constant, careful management, especially when your goal is to produce all-male fish.
The genetic quality control pretty much never stops. You have to bring in new, unrelated fish every so often to keep the gene pool fresh and healthy. You're keeping detailed records on every single fish, often using tags to track them. Any fish that isn't performing well or shows defects gets removed from the breeding program. And the golden rule: those YY supermales are kept in complete isolation. Just one accidental crossbreeding could mess up the entire genetic line you've worked so hard to build.
So, to get the absolute best results when it's time to breed, hatcheries follow a very specific conditioning protocol. It starts with separating the males and females for about 10 to 12 days. During that time, they're fed a special high-protein diet to really boost the quality of their eggs and sperm. Then, right before breeding, every fish is checked to make sure it's in perfect reproductive shape. Think of it like this: a stable environment is just as critical as top-tier genetics. These optimal water parameters have to be nailed down 24/7. The temperature needs to be in that sweet spot between 27 and 29 degrees Celsius. Oxygen levels have to stay high, and waste products like ammonia and nitrite have to be kept close to zero. Any little swing in these numbers can stress the fish out and completely ruin a spawning cycle.
And holding all of this together is a rock-solid biosecurity program. This means strict quarantine is always enforced, daily health checks are mandatory, all water leaving the facility is sterilized, and there are strong barriers in place to make sure no diseases get in or out. It's just part of the daily grind.
And that brings us to our final section. And this is where things get really interesting: YY supermale technology. This is where modern genetics completely changes the game, making it possible to reliably produce huge batches of all-male tilapia.
So, what in the world is a YY supermale? Okay, so normally, a male tilapia has an XY sex chromosome pair, just like human males. But a supermale has a YY pair. Now, this doesn't just happen in nature, it's the end result of a pretty clever and specialized breeding program.
Creating one is a really fascinating process. Stick with me here. First, you take a regular genetic male, an XY fish, and you use hormones to turn it into a female that can actually produce eggs. We call this a neo-female, but genetically, it's still XY. Then, you breed this XY neo-female with a normal XY male. Since both parents can now contribute a Y chromosome, some basic genetics tells you that about a quarter of their babies will end up with that special YY combination. And voila, you have a supermale.
And this is where the magic really happens. When you take one of those YY supermales and you cross it with a normal XX female, what do you get? A batch of babies that is 95 to 98% all male. It's that incredible reliability that makes this technology so valuable for commercial farms.
So you might be wondering, why go through all this trouble? What's the big payoff for a commercial hatchery to use this kind of advanced technology?
Well, there are 3 huge advantages. First off, it's a simple fact. Male tilapia grow bigger and faster than females, so you get a better harvest. Second, having an all-male population means no uncontrolled breeding in your ponds, which leads to overcrowding and stunted fish. And third, you get this all-male result through genetics, which means you completely avoid using controversial hormones. That's a massive win with consumers and regulators.
So let's put them side by side. The YY method is a clean, genetic solution. There are no chemicals, no residues, and it totally sidesteps public concerns about hormones in their food. The old way, hormonal sex reversal, requires adding steroids to the fish feed. That's not only tricky to get just right, but it's also facing more and more public backlash.
But, and this is a big but, using this technology isn't a walk in the park. It demands absolute genetic purity, and it only really works with specific red and silver strains of tilapia. The strict isolation of the YY males is non-negotiable, and so is keeping meticulous records and having that tough-as-nails biosecurity program. There's just no room for error.
And yeah, there are some pretty significant downsides. It's expensive to import these fish, and because of patents, you can really only buy them from a couple of hatcheries in Europe. Anytime you bring in live animals from overseas, you're taking on biosecurity risks. And there's a genetic catch, too. Since the father's genes are locked in as YY, all future genetic improvements have to come from the mother's side of the family.
Just to put that cost into perspective for you, the freight fee alone to get YY males shipped to a place like Trinidad can be around $1,200 US. That's a serious upfront investment for any hatchery, big or small.
So when you put it all together, here's the bottom line. Despite the high costs and the strict requirements, YY technology is a reliable genetic key to producing huge numbers of all-male fry. It directly solves the age-old problem of overpopulation in tilapia ponds, making the entire farming operation more efficient, more competitive, and in the end, more profitable.
And that leaves us with a really important question for the future of aquaculture. As these genetic tools get even more powerful, how does the industry strike the right balance? How do you weigh that constant drive for more efficiency and profit against the very real risks of high costs, genetic bottlenecks, and biosecurity threats? Something to think about.